are working with others in your schools that are teaching climate change. So that's good news. And I'm happy to be here. This is kind of an experiment, obviously. I mean, I've been involved with webinars, but we'd like to try to make this as interactive as possible. And I think Julie will plan to send she'll help facilitate questions at your end and notify me via the chat here if there's any questions that come up. But and that I believe you all have hard copies of that. Also, the energy literacy framework, and these are documents that I was involved with helping to develop. The original climate literacy framework dates back to about 2007 when we first started working on that. And then energy but in any event, let's go ahead and get started here. And again, if there's any questions that you have or comments, you can put them in the chat, and then Julie can forward them on to me. But over the course of our time together, I'd like to talk a bit about what is science literacy, and obviously there's different definitions for that. Also talk about why climate and energy literacy are important, and what are some of the challenges and opportunities and I don't know how many of you are familiar with it. Maybe you can raise your hands. We can try out that little icon up at the top there where you can just raise your hands if indeed you are familiar with the National Center for Science Education. But we've actually been around also a Facebook page and a Twitter, and we also have many YouTube videos, primarily of our executive director, last 20 years. But she's helped spearhead this new climate change initiative that I've been at the University of Colorado working for CERES, the Cooperative Institute for Research in Environmental Sciences. And I know that Emily from CERES will be coming to speak to you tomorrow. And I think focusing more on some of the All right, so that's just a little overview of NCSE. We do have a website, as I mentioned, that includes this new climate change initiative. And within that website, I would which I think most of you are probably pretty familiar with the basics of climate change. And particularly how that comes up in the classroom. I'll be talking more about that shortly. And how you can support good climate change education at your local school, at your school district, and also at the state and national level. I'll be giving you a few quick examples of the type of things that NCSE does, but we assist with what we call flare-ups, and I'll give you an types of events that we call flare-ups. Basically, they're kind of hot spots that we focused on people teaching creationism in public schools. Efforts to teach that climate change isn't happening, which unfortunately is fairly common practice. But in some cases at a state or school district level, we do engage with local activists who are supporting strong science education. We also build networks of scientists and clergy and so forth to evolution and climate change. And we lobby for good science education standards. I believe you've all had an overview of the next generation science standards, and I four or so next generation. Many of them, almost 30 of them, address climate change or other human impacts on the environment. But we also try to connect teachers with good educational materials. We analyze some of the bad materials that are out there from climate skeptics and so. Media, we talk a lot with the media to try to help educate them about these issues. From the New York Times, to planning to write a story about climate change denial in Louisiana. We had a call from a parent in Clifton Park, New York, was basically saying that climate change isn't happening, that you students should be critical of anything that Al Gore and you know, is not necessarily a good film to show in a classroom, particularly a science classroom, because it has a kind of, there's much better and inconvenient truth. But in any event, this parent was concerned, and so we were able to help guide her through the a major issue. And what we suggested that she do was sit down with the teacher and another teacher to try to work it out at the school level, rather than have it escalate up to state. And what ended up happening is that I think the teacher was informed by the principal that you cannot you cannot teach that climate change isn't happening because the teacher had signed a contract with the district. He was going to be teaching the curriculum, and basically was threatened with a and he claimed that he was just misunderstood. But in any event, with that parent, and help her through the process of kind of confronting the teacher and making sure that climate change. You know, I'd be curious to hear from all of you, and maybe we can do that when we sort of open up for questions. But or somebody, another teacher perhaps, or they should teach both change to make it fair and balanced. And I'll talk more about why that's not a good practice. That gives us hope that climate change can be taught throughout the curriculum in a very are well grounded in the of the science. Talk about climate. I'm sorry, science literacy in general. There's a researcher from Michigan State named Jonathan Miller who, for the past to read the science section of the New York Times and be able to more make sense of what's being described there. So, in other words, you don't need appreciate the process of science enough about the content so you can kind of decipher an article and John Miller has determined by people going to college and graduating from college, obviously to get into college you need to have the college board requires about 3 years of science for schools to but I think many of you are also aware that states vary in terms of California. It's only, there's 2 years of science required for graduation from high school, and in fact cut costs on science education. I think many of us feel that's very unfortunate. Science to graduate, but for some students, obviously, science is not very engaging or boring or irrelevant to their lives. But in many cases, that's perhaps in the South. Be that as it may, idea of civic science literacy is that how science is kind of self-correcting, and then be able to make informed choices based on that understanding of the basics of science. So going back to some of the good news, until it was developed a couple of years ago, and as I think all of you are familiar, there's the, the we also have the guiding principle for climate decisions. Humans can take actions to reduce climate change and its impacts. That guiding principle is often overlooked, but it's really important because understanding the basics of the science and how climate science is conducted, make choices, we can take actions to minimize the impacts of climate change and prepare ourselves for changes that are already well underway. That's also available through the globalchange.gov website, the U.S. Global Change Research Program. And likewise, there's 7 principles, and I won't get into them right now. Physicist from the University of Colorado is at the White House. He's the #2 science advisor, John Holdren being the primary science advisor at the White House. But Carl Wyman super involved with physics education over the years to help with science, particularly science education at the White House. For teaching and learning of energy literacy. And it basically builds on research that the National Academies has summarized in some of their so this guiding principle really focuses on those effective learning opportunities. It's in the very back of the energy literacy and basically alpha time. discussion today. Julie's asking a question about some of the better media sources besides an resource I'd very highly recommend is called Earth, the Operator's Manual, which is featuring Penn State geologist and climatologist Richard Alley. And they have a wonderful website. They've got a book. They've got video clips. They've been part of a PBS Nova series called Earth, the Operator's Manual. So they're doing some fantastic work to help sort of demystify how climate science is conducted. And they focus a lot on what the military the U.S. military is the #1 consumer of fossil fuels on the planet, and so they're making a big push to on the environment, but also in terms of national security. The less they're dependent on carrying fossil fuels across enemy territory, the better off. Really good resource is CLEAN, the Climate Literacy and Energy Awareness Network that I suspect many of you are familiar with. CLEAN website, which is CLEANET.org. And in any event, vetted for scientific accuracy and pedagogical potential. So if you're not familiar with CLEAN, please take a look. There's also a whole section within CLEAN on teaching about climate and energy and why they're important. That teaching about section also focuses on some of the misconceptions that come up around some of the other good news I'd like to highlight is the Alliance for Climate Education, and I'm curious. ACE, and they've got a very cool website that is acespace.org. Northern New York, and they've got one in Chicago and I think Atlanta and Asheville, North Carolina. So that ACE come and give a high school assembly. The assemblies are very engaging. By and large, teenagers really get motivated and inspired by these assemblies. The science is very good. You've also talked a bit about the next generation science standards, and as I mentioned, nearly 30 of them address climate and global change topics. Probably late winter, more likely next spring. But there's still quite a few challenges before the has been kind of critical of the way some of the standards are put together. And so there's currently with developing these standards, which are based on the National Research Council these are widely adopted and deployed, I think recognize that there's a lot of potential science standards right now, or in some cases it's barely touched on. And I know that some of you indicated that you don't teach climate change or you probably don't have standards that include climate change in them. I mentioned New York State and their 8th grade earth science standards does include other states. For instance, Texas does have climate change pretty well represented in obviously the most something that the folks at Achieve, which is a nonprofit organization that helped shepherd the next generation science standards through the process. Something they did to kind of build support for these new national standards is conduct a poll looking at people's attitudes towards existing science education, and 84% of the public feels that science education is extremely important or very important, and very, very few people feel that it's not important at all. Moreover, most in some cases they gave their local schools A's and B's, but often they felt that the grade they would give science education nationally would be a C or less. And I think many of you might have seen the ads that ExxonMobil has been promoting recently, pointing out the fact that the U.S. is not doing well internationally with our math and science skills, and is a lot of soul searching about why that is. So ExxonMobil has been pushing for stronger math and science programs, and in fact they fund a big teacher development workshop in Houston every summer that the American Geoscience Institute is involved with. But this, going back to the survey, they found that only about 9% of the people they surveyed oppose new national science standards, which is somewhat surprising. I thought it would have been higher than 9%, but that's, I think, good news in many respects. More good news is that the vast majority of climate experts, in other words, climate scientists who publish in peer-reviewed journals, think that humans are changing global temperatures. I mean, that in a way that is not the good news is that there's such strong consensus. In fact, I think it's higher than 97%. But because even some of those who are considered part of those 3% that don't think humans are changing global temperatures actually have said publicly that they do think it is a contributing factor, but think there's other things involved besides greenhouse gases. But so let's turn now to some of the not so good news. Here's a cartoon that expresses a common misconception: why don't greenhouse gases escape through the ozone hole? And I think many adults grew up and perhaps took science classes in high school in the 1980s, when there was a huge concern for the fact that human chemicals, specifically CFCs, were linked to the deterioration of the ozone hole, or the ozone layer, creating an ozone hole that allowed more ultraviolet radiation to reach the surface of the Earth, and the concern was that that could lead to more skin cancers and similar types of problems like that. But obviously there are a lot of misconceptions, and if there's time towards the end of the presentation, if any of you have questions about particular misconceptions and how to handle them, I'll try to answer them. As I mentioned, the CLEAN website has a whole section that tries to walk through. Also, some of the not so good news is that while the scientists are confident that climate change is happening and humans are largely responsible, politicians look at different data and realize that talking about climate change can be a problem depending on who your constituencies are. And so, unfortunately, and finally, here's a cartoon that talks about kind of the emotional challenge of dealing with climate change and related topics, where the teacher is saying, I'd like you to tell me what you would have liked to be when you grew up had your predecessors not doomed you to a catastrophic wasteland. And I think that the doom and gloomy as being very, very alarmist, and that's one of the challenges of effectively teaching climate change is how do we teach it in such a way that students don't get completely depressed and overwhelmed. At the same time, we need to convey the basic science very, very discouraging. But that's why, and we'll come back to this point over and over again, that's why it's really important to weave in solutions and give students the sense that they can be empowered, that there's choices they can make, that there's careers they can pursue. At moments, it feels like an overwhelming topic. So just as a reality check, the Six Americas research group at Yale, the Tony Lazarowitz, who works with the Yale Forum on climate change in the media, also works with the climate communications group at George Mason University. But they've conducted research that found they were specifically looking at teenagers and their knowledge of climate and related topics, and they found that fewer than 20% of secondary students felt very well informed about climate science and solutions, and only 27% felt that they learned a lot about global warming in school. Most teens and most adults, according to this survey and other surveys, would basically flunk a quiz on the basics of climate and energy. And I think that's probably no surprise. Both climate and energy are very cross-cutting topics that tend to fall through the cracks and just have not traditionally been well taught. So I think that's certainly one of the challenges that we all face is how to address this enormous gap that has been going on for many decades. The National Research Council held a workshop, actually a series of workshops on climate change education, and they identified 4 key issues around climate change. The first one, of course, is that the science itself is very complex. It also crosses many disciplines, so climate change, maybe would be taught in an earth science course, although earth science courses tend to be kind of more geology focused traditionally, and obviously climate change could be taught in a physics or biology or chemistry course, but because there's complex physics and chemistry and biologic components to climate change, but all too often it's missing from those traditional courses. The other aspect of climate change is that there's such an important human dimension that to be taught effectively, it really needs to be taught across the curriculum in social studies courses, maybe even in history courses, talking about the history of modern civilization and how fossil fuels have led to many advances technologically and in terms of our standard of living, but there's also been kind of this shadow side in terms of the environmental and climate impact of our dependence on fossil fuels. Climate and energy have not been well represented or coordinated traditionally. In the mid-1990s, the national science standards deliberately did not talk about human impacts on climate. They also didn't talk about human origins, human evolution, because both were considered to be just a little too controversial at the time, which I think is really unfortunate because there's strong science, and there was strong science even back in the mid-90s about both of these topics. But evidently the people putting the national science standards together in the mid-90s opted not to include them because those two topics, human evolution and climate change, were just a little too controversial. Unfortunately, climate change in particular is still considered to be politically very controversial, and clearly it's very polarizing. Probably more so now or in the past several months than it ever has been. And then finally, this wasn't included in the work that the National Research Council workshop on climate change education put together, but there is this emotional and psychological dimension, sort of the affective domain, if you will, to climate change that I alluded to a moment ago. And we'll talk more about that in a few minutes. So, in fact, why don't I guess Christopher is asking, does anyone have a good print resource that addresses climate issues at the middle school level? It's balanced between gloom and doom and hope for solutions. And again, I would recommend going to the CLEAN website, CLEANET.org. You can search on resources by grade level, by subject topic, and one of the great things about CLEAN is that it really steers away from the gloom and doom, and really focuses on helping students master the science content. There's a lot of energy-related topics, particularly at the middle school level, actually. So I think that's a wonderful resource. And also, Kelly's asking a question about where there's controversy that it's a major distraction from being able to focus on the scientific content and the principles that you're trying to help students master. And I'll talk a bit more shortly about the controversy and how to try to deal with that when it comes up. But I think that's one of the key concerns for a lot of teachers these days. A few years ago, actually, the big concern was helping teachers master the content, which is complex, and of course many teachers themselves themselves never had a background in climate science, so they were struggling to come up to speed and be able to confidently teach the science. But more recently, teachers are telling us that they're dealing with controversy. They're dealing with parents who are complaining about, you're scaring our kids, you shouldn't be teaching this, there's both sides to the argument, so you should be teaching both sides. And all of that distracts from being able to really focus on the science itself. A colleague of mine at the University of Colorado, Susie Strife, who now works for Boulder County with their Climate Smart program, did her PhD thesis on the attitudes of young people. These are 10 to 12-year-olds in different parts of Denver, and she was looking to find out about their attitudes towards nature in general. So this wasn't a study really focused specifically on climate change, but what she was focused on was how do youth, particularly the 10 to 12-year-olds, experience nature, how do they define nature, where do they find nature in their daily lives, and how do they feel when they're in nature. And I'll just be highlighting a couple of the findings of her study, but she looked at kids in inner city Denver. Some of the kids in inner city Denver had never ever been to the mountains in their whole lives. They can see the mountains from Denver on a clear day, but many of them had never been given the opportunity to get up in the mountains. She also looked at some students from Cherry Creek district, which is like Boulder. It's very affluent, and many of the kids in Cherry Creek thought of nature as the Galapagos Islands, where they went on vacation, or some other distant place that they experienced traveling. So one of the interesting things was that she found was that many of the inner city kids thought of nature as what the tree out the back door or in the park across the street. Unfortunately, a lot of the kids in the inner city felt their access to nature was really cut off because of concern about gangs at the local park and things like that. In the case of the wealthier students from more affluent communities, the issue for them was that they didn't have time to just hang out like many of us did when we were kids, playing in the creeks and going hiking in the hills or whatever, because a lot of kids today, have soccer practice or after-school programs, et cetera, and both parents are working. So oftentimes they don't just have the time to be able to experience nature directly themselves. They haven't had the chance to mess around, or their parents are afraid the kids will get kidnapped or whatever. But in any event, what Susie found in her research was that there was really quite a dichotomy in many of the students' minds about the future of nature. That many of the 10 to 12-year-olds felt that the Earth was endangered now, but fairly healthy, but that in the future, if we don't take care of the planet, it could be really bad news. One of the interesting things that Susie did was had the students use artwork to express themselves, and sometimes they would draw maps of the neighborhood. Sometimes she would ask them, how do you feel about nature, and they would draw their feelings on paper. She also interviewed them, so it wasn't just through the artwork that she kind of teased out these were two major emotions that came up when students thought about the environment, and one was fear. The students were very concerned about the future of the planet and the future of the environment. And a lot of students admitted that they had dreams that were kind of apocalyptic. Most of the students were getting their information from movies rather than from classrooms. And obviously there's a lot of gloom and doom video games and which, you know, for better and for worse, it does impact the students' emotions. They also felt a lot of sadness. So fear and sadness were really the two emotions that came up for these students. And it made them often kind of angry too. So I think that this is a sentiment that certainly I can relate to. You know, I grew up in the 1960s when the biggest concern was nuclear warfare, and I'm old enough to remember vaguely the Cuban Missile Crisis. I was a young kid back in the early 60s, but there was the threat of nuclear annihilation and nuclear war between the Soviet Union and the U.S. By the way, that is still a threat that looms over us. You know, we don't talk about it much because you know, climate change is quite a bummer, but the possibility of a nuclear apocalypse is even more of a bummer. And yet it really is a very real threat that we just tend to tune out. So I think that there's obviously not a lot of controversy about what could happen if there were a nuclear war. And in fact, Alan Robach, who is at the Rutgers University in the Department of Environmental Sciences, has been looking at the climate impacts of a nuclear conflict. This dates back to research conducted in the 70s and 80s that they often describe as nuclear winter research. And the concern is that even a small nuclear war, like between Pakistan and India, could cause huge impacts on the global climate system and impact agriculture in a substantial way around the world. So this is just a reality that, again, we don't like to talk much about. You know, during the 1980s, there was tremendous buildup of nuclear weapons. Tens of thousands of nuclear weapons were made in the U.S. and the Soviet Union. We still have many thousands, even though we've reduced down from the tens of thousands to several thousand. But there's still more than enough nuclear weapons out there. And one thing that Alan Robach and his colleagues have done is look at what would happen to the climate if there was even a small, relatively small nuclear war between, say, Pakistan and India. If they set off their Each of them, I think, has about 10 nuclear atomic weapons, and if they set them off, it would create on the order of 5 teragrams of smoke, and um, that would plunge the temperature very dramatically. So even this small, relatively small nuclear war would be unprecedented in terms of the global climate change that could occur. So this is a chart showing what would happen if there was even a greater exchange of weapons. So the 150 teragrams of smoke and yeah, I guess that 150 teragrams of smoke, which would be the equivalent of a massive war between the U.S. and China, perhaps, or U.S. and Russia, would plunge the temperature as much as 9 degrees Celsius, or roughly 20 degrees Fahrenheit. And needless to say, that would be really catastrophic in terms of the impact on the global climate system and agriculture and so forth. So people are looking for the quick solution to global warming. Unfortunately, nuclear exchange would be the opposite of a good solution. So I see that there's a question from Christopher, wondering if students right now wouldn't be more connected to nuclear accidents than nuclear war. So I think in the case of nuclear accidents, basically the concern there is radiation. In the case of nuclear war, certainly radiation comes into play, but it's actually more the smoke and dust that would go up into the atmosphere and block the sun and cool the climate that is the big concern here. So I'm not advocating that you talk about nuclear war into your science classroom, certainly not at the middle school level and maybe not even at the high school level. At the same time, it's a reality or a possibility that by and large we try to ignore because it's extremely gloom and doomy, to put it bluntly. In terms of climate implications of the accident that happened at the Fukushima plant after the tsunami last year, again, that was really focused on the radiation release and how that impacted the food web, and how that could get into the impact on the climate system, because you didn't have the dust and smoke that you would get from a nuclear war, an exchange of nuclear weapons. So looking at Earth's past history, the Earth has experienced 5 mass extinctions, the biggest one being the Permian mass extinction. And when something on the order of 90% of life on Earth was wiped out, the most recent one was roughly 45 million years ago, and there's a lot of concern among, especially biologists, actually, more so than maybe climate scientists, that we are in the midst of a sixth mass extinction due to human activities, climate change being one of those activities. So I think it's really worthwhile pointing out that human activities go way beyond just climate change. We are a force of nature. There's 7 billion people on the planet, heading towards 10 billion people, and we move more dirt on the planet than all the natural erosion processes combined. We fix more nitrogen on the planet for fertilizers through a process that is very fossil fuel intensive, and we fix more nitrogen than all the bacteria on the planet. We alter both the nitrogen and phosphorus cycles, again, mostly for fertilizing. We're acidifying the ocean. Of course, that's in part related to the burning of fossil fuels and the carbon dioxide that goes first into the atmosphere and then into the oceans. We don't even really know the full extent of chemical pollution on the planet. There's this sort of toxic stew of chemicals that oftentimes, even with a good waste treatment plant, sewage treatment plant, this soup of chemicals goes right into the waterways, into the streams, into the ocean, and we don't really know the full extent of how that impacts the hormonal systems of fish. In fact, in Boulder, there's been some really interesting work on Boulder Creek, downstream from the sewage treatment plant, looking at endocrine disruptors. These are chemicals that in some cases come from plastics that get into the water cycle, and we flush them down the toilet and so forth. And they are impacting the hormonal systems of fish downstream from the waste treatment plant. So that's a whole other area that we don't have a good handle on the human impacts on the environment. We also are impacting the ozone layer still by the use of certain chemicals. I think many of you are familiar with the Montreal Protocol. That was an international treaty that Ronald Reagan helped spearhead that banned chlorofluorocarbons, CFCs, that were the main culprit destroying the ozone layer. But the ozone holes, particularly in Antarctica and to a lesser extent in the Arctic, are still there, and there are still chemicals that are chewing up the ozone layer. Aerosols from human activities, of course, aerosols make people think of hairspray, and what we're really talking about here are dust particles, or maybe in some cases soot from the burning of charcoal, excuse me, wood and charcoal, black carbon in different parts of the world. And that aerosols can have a dampening effect on the climate by actually cooling the climate. Along the lines of after a nuclear war event, you've got the dust and the soot and the smoke from the fires and so forth, and that can create the cooling effect. Likewise, aerosols and particles from the burning of coal can have a cooling effect. But at this point, that cooling effect is more than made up for by the warming effect of greenhouse gases from human activities. And I see there's a question about research on endocrine disruptors, and there's there's a book that came out actually almost 10 years ago that focused on endocrine disruption, and I can't think of the name of it right now, but I think if you just do a Google search on endocrine disruption, you'll find some really good sources on that. Fresh water is also a big issue. There's more and more people and less fresh water. You know, electricity goes to cleaning and pumping water, and so that when we have fresh water here in California, there's also a lot of energy sort of embedded in the water. And likewise, when we generate energy, whether it's through a coal burning power plant or a nuclear plant or a hydroelectric plant, water is involved, and in some cases, huge amounts of water. Biofuels, some of the recent research on biofuels from saltwater algae are potentially very revolutionary, because you don't need fresh water to generate those type of biofuels. Also, land use change is an enormous issue. We have transformed the surface of and there's some interesting animations. The climate timeline actually has a very interesting animation over the past, looking at climate change. I'm sorry, looking at land change in North America over the past several centuries. And you can see the forests basically being chopped down and replaced by huge agricultural monoculture farms and so forth. And then finally, biodiversity is another important factor in global change. You know, in some cases, the loss of biodiversity is related to the warming climate, but more often it's actually related to the changes in habitat, the loss of natural habitat, where we, drain swamps and turn forests into cornfields and that type of thing. So